All right, welcome back, everyone. So today we're going to talk about properties of logarithms. In this section, we're going to talk about the properties of logarithms, including the product, quotient, and power rules. We're going to talk about how to use the properties of logarithms to expand logarithmic expressions and how to use them to simplify expressions, and then how to use identities to simplify expressions or simplify logarithmic forms. So the first rule we need to talk about is what's known as the product rule. Basically, if you have the logarithm of a product, it's the same as the sum of the logarithms of each of its constituents. So log base a of m times n is going to be equal to log base a of m plus log base a of n. And notice that the bases are the same. Bases have to be the same in order for this to work. So for example, the log of 15 is the same thing as the log of 3 times 5. And if you plug log of 15 into your calculator, you're going to get 1.1761. And we then break up those two factors and say the log of 3 plus the log of 5. You'll get those two numbers there, and when you add them together, you get 1.1761. And so it's the same number, regardless of how you do it. So what this means is you can rewrite a product as a sum, or you can rewrite a sum as a product. So let's try this. We have log base 3 of 9x. Well, that 9x is a product. It's 9 times x. And so we can rewrite this as log base 3 of 9 plus log base 3 of x. We're just expanding it into a sum. We're not quite finished on this one. Log base 3 of 9 we can actually calculate. What power do you raise 3 to get 9? Well, that's equal to 2. And so we just get 2 plus log base 3 of x. If you can simplify the logarithms, do it. For the second example, we have the natural log of x times y. And the natural log of x times y, well, we have a product. We can rewrite this as the natural log of x plus the natural log of y. And finally, going the opposite way, if we have 3 logs added together, we can combine them all as a single product. So we have log 2 plus log a plus log b. We can combine this as one log of 2 times a times b, or just log of 2ab. So we just went the opposite way. We took the sum and combined it into a product. So you should be able to go both directions here. Now the next rule is very similar. It's called the quotient rule. And the quotient rule just says that the logarithm of a quotient is the same as the difference between the two logarithms. So you're subtracting. Notice here that the negative term is the one from the denominator. So for example, the log of 15 over 5 is 3. The log of 3 is going to be equal to the log of 15 minus the log of 5. You can check this with your calculator. You can also go back and look at the previous example in the product rule and notice that, of course, it's the same thing. Thus, we can expand quotients and simplify just like products. So here we have log base 2 of 19 over x. And so we have the log of two things divided. We can rewrite that as a difference. This is log base 2 of 19 minus log base 2 of x. And notice that the minus goes in front of the one in the denominator. We can do the same for the second one. We have the natural log of u divided by v. Well, that's the natural log of u minus the natural log of v. Notice the numerator is positive, the denominator is negative. And finally, going the opposite way, we have the log of 10,000 minus the log of 100. We could rewrite that as one log with a quotient, 10,000 divided by 100, which we divide 10,000 by 100, we get log of just 100, and the log of 100 is just 2. Finally, we have what's known as the power rule. And that just says if you have the logarithm of a number raised to a power, then it's the same as just multiplying the logarithm by the power itself. So essentially, the exponent can be moved in front as a constant. So we have something like the natural log of 9. That's the same thing as the natural log of 3 squared. Right? 9 is 3 squared, which is 2.1972. We then rearrange that, and we look for 2 times the natural log of 3. Well, that's 2 times 1.0986, which gives you 2.1972. We get the same answer. And so once again, we can use this rule along with the other 2 to expand or simplify logarithms. What we're going for is using these rules all at once, all together. So we want to rewrite these expressions using the product, quotient, and power rules. So let's start with the first one, and we'll probably have to go to other slides for the next couple. We have log of x squared y cubed times z. So this is the log of a product. We've got 3 things multiplied together. So let's first rewrite it using the product rule. We're going to expand this and say the log of x squared plus the log of y cubed plus the log of z. Now we have the log of different variables raised to powers. We can then use the power rule to rewrite this one more time. All of our exponents are just going to move in front as constants. Right? This is actually z to the first power, so that's not going to change. And so what we get is 2 log x plus 3 log y plus log z. And that's it. So first we use the product rule, and then we use the power rule. Let's try the next one. We'll go to the next slide. We have the natural log of a squared times c over b to the 1/3. Well, this is the natural log of a quotient and a product. We can do the product and quotient rules at the same time. Just remember the products are positive, the things in the numerator are positive, the things in the denominator are negative. So we get the natural log of a squared plus the natural log of c minus the natural log of b to the 1/3. We use the product and quotient rule at the same time. The ones in the numerator are positive, the ones in the denominator are negative. Now we use the power rule. All the exponents are just going to move in front as constants. And so what we'll get is 2 times the natural log of a plus the natural log of c minus 1/3 times the natural log of b. And that would be our solution. Finally, part C was 1/2 natural log of x minus 5 natural log of y plus 2 natural log of z. Now we want to condense this. We want to simplify this logarithm. And so to do that, we're going to do things in reverse. Let's first make all of the constants into powers. We're going to do the power rule, but in the opposite way. All of the constants in front are just going to become powers. And so what we get is the natural log of x to the 1/2 minus the natural log of y to the 5th plus the natural log of z squared. And now we can use the product and quotient rules together to combine them all into one logarithm. And just remember, the positive ones go in the numerator, and the negative one goes in the denominator. And that would be our natural logs, to condense the thing down. So we can use all of these rules to expand complex logarithms into its components. Okay, so let's just look at this as a separate problem. We've got the natural log of the cube root of w to the fourth v to the fifth over c cubed. Anytime you have a log of some root, it is always easiest to turn that root into a power first. So let's first just rewrite this. We're not changing anything yet. We're just going to rewrite this as w to the fourth v to the fifth over c cubed to the 1/3 power. All we do is take the cube root and make it to the 1/3 power. Now remember, when we raise a power to a power, we multiply. And so w to the fourth power raised to the 1/3 power, that's going to give us w to the 4 times 1/3, or 4/3. V to the 5 times 1/3, which is 5/3. And C to the 3 times 1/3, which is just 1. Now that we've simplified this a bit, we can rewrite it using those rules. So first, let's expand it out using the product and quotient rules. The numerator remains positive. The denominators become negative. So the natural log of w to the 4/3 plus the natural log of v to the 5/3 minus the natural log of c. And now we can just take the exponents and turn them into constants in front. So we get 4/3 times the natural log of w plus 5/3 times the natural log of v minus the natural log of c. And this would be our answer. So if you have a root, go ahead and change it into a fraction power, multiply the power through, and it makes things a lot easier. Now sometimes when we condense logarithms, you can actually simplify it beyond just the rules that we have. So here we have the natural log of x squared plus 7x plus 12 minus the natural log of x plus 4. So we have a difference of logarithms. We can rewrite this by just saying the natural log of x squared plus 7x plus 12. So the positive one's in the numerator, negative one's in the denominator. But we can now factor that numerator. This is the natural log of x plus 4 and x plus 3. And notice now the x plus 4's will cancel, and we're just left with the natural log of x plus 3. So by combining those logarithms, we were actually able to simplify it more than just using the product and quotient rules. So we can sometimes use these identities, and we talked about these at the end of the last section, and we did a couple of examples. We're just going to do a few more here. We can use these identities to solve problems. So for example, we have 3 to the power of log base 3 of 5x. So forgetting about the first 3, what this log is saying is what power do you raise 3 to get 5x? And that's what this is going to be equal to. And then we're going to raise 3 to that power. If you look at your identities, a raised to the power of log base a of x is just equal to x. Right, so that's this one. And so 3 raised to the power of log base 3 of 5x is just going to give you 5x. Similarly, e to the natural log of 8x, if we look back at our identities, e to the natural log of x is just x. So e to the natural log of 8x is just 8x. And then finally, the natural log of e to the 3x. We look back at our identities. The natural log of e to the x is just x. Now we're using this one. And so the natural log of e to the 3x is just 3x. No work to be done on these problems. You just have to recognize that you can use those identities. So at the end of this lesson, you should be able to expand logarithms using a product, quotient, or power rule. You should be able to simplify them using product, quotient, or power rules. And you should be able to simplify logarithms using those identities we just talked about.